Now here we have the IR, infrared spectroscopy, and what we'll do is make up two samples, one a liquid and one a solid, and show you how to run both of those so that depending on which type you have throughout the lab, you can figure out how to run it. But for a liquid, they're really easy. All you need to do is take a drop or two, put it on the salt plate, put the salt plates together, and then carry them over and stick them into the instrument. And then once it's in the instrument, you come over to the screen and click on the collect sample button, and it may ask if you need to run a new background. You can just click no, and then click the sample is ready to run button, and it'll run, and it'll tell you how far along it is in the 1 of 16 scans. About halfway through, it'll put up a sample spectra there of what it looks like that it's working towards coming up with for your final spectra. And then when it's done, you know when it's done by over here it'll say 16 out of 16 scans completed, and you can title it. If you print it out on a full page, the title doesn't end up showing, so you don't necessarily need to title it unless your instructor tells you to. And then once you have this, your instructor may want you to peak pick. If you're in my lab, I prefer you not peak pick because I want to see the full spectra printed out on an 8.5 by 11 sheet of paper. And then you can come over and hit print and check and make sure it's going to the right printer. We're in Howell Hall 355, so we want to make sure it goes to the printer there, and hit print, and it'll come out of the printer in a minute or two. And when we look at our spectra, we see that it does look like something that we've seen in lecture. It doesn't look weird or anything, so we know we ended up getting a good spectra. You can print out 2 copies of it if you need to, one for in your lab notebook and one to turn in with your lab report if your instructor wants you to. And that's how we do a liquid sample. To clean up the samples, what we need to do is take them back out of the instrument. We have some methylene chloride over here. We take the sample apart, the 2 pieces of the salt plate, and we can squirt a little methylene chloride on them to clean them up. And then quickly take it out with a Chem wipe and dry it off, because since it is sodium chloride, you don't want any water to get on it or it'll end up pitting it and dissolving your salt plate. And then we need to do the same thing with the other piece. With a little bit of methylene chloride, spray it off on both sides, and then dry it with our Chem wipe. And then we're ready to make our next sample. And the next sample that we're going to make is a solid. And they're a little bit harder to do. They're kind of a hit or miss as we're going about doing them. It may take a few tries to get a good sample. What we'll do is take a small amount of our solid, put it on a watch glass, and then 1 drop of mineral oil. And just 1 drop, we don't want very much. And then we'll grind the compound and the mineral oil together to make a nice mole. And then we can put it on our salt plate. And then put the salt plates together. And as you're doing this, you can tell if you have a good sample or not just by what the salt plate looks like. if we look at this one, we see that there's a lot of compound in between the two salt plates. So what we'll need to do is wipe a little bit off because we have a little bit too much on there, and grind them together again. And wipe off the extra compound, grind it together nice and good. We'll stick it in the IR and see what it looks like. We may have to wipe off another plate. Set it in there, make sure the beam is going through it. Hit the collect sample button. We don't need to collect a new background. The sample's in there, so we say OK. And we'll see what it looks like. If we have too much solid on the plate, what will happen is the percent transmittance will be really low. And see, this is down at about 7% transmittance. So we have too much solid on there. So all we need to do is take our sample out. We don't need to let it finish running because it's not going to get any better. And we don't have to wash the plates. All we need to do is wipe off one of the plates on our Chem Wipe. Put them back together, grind it up again, and then add it in to the IR and run our next run a sample again. Now we could have let the last run finish, but it wasn't going to get any better because we had too much stuff on there, so we could just take it out and wash it off, or you can let it finish if you want to. So this one, now we're up to about 18% transmittance. It's looking better. We see in our sample we have two peaks down around 7 and 750. We have the four little peaks in the 1700 to 2000 region. So we know from that we have a mono-substituted aromatic ring in this sample. So we can print it out, and then that's a nice looking solid sample. The solids won't necessarily look as good as the liquids, but you should get a nice looking solid. Now as you're running the IR, every once in a while it has a glitch in it, and it'll end up putting up on the screen something that looks kind of like a sine wave. If that happens, all you need to do is just hit collect sample again and run your sample again. You don't have to clean anything, you don't have to change anything, just run the sample again, and usually the second time that bug in the instrument works its way out and you get a nice looking spectra. But you know, anytime you run an IR, it should look like something that you've seen in the lecture for the class. And if it looks really, really bad, you know you don't have a good IR and you need to do something to change it to make it look better. And if you can't figure out what kind of change you need to make to get a better looking IR, be sure to talk to your professor about it so that he can give you or she can give you some advice on how to get a better IR from the instrument.